Hi folks, this is Karim Raouf from our IT Visualizer channel. They will continue our Lambda Matrix Labs, the video number 38. We have been discussing in the previous video the following. We have been still working on the report which is called Testomo report, which is a report built on PowerShell commands. The output is a very organized and well done HTML report. Okay, it contains a lot of useful information concerning the health of the Active Directory and the security of the Active Directory and a couple of issues concerning the backup of your Active Directory. So the report focuses on a lot of aspects concerning the Active Directory, the health, the security, and the backup. And actually, it is a very useful one. It runs 644 tests concerning all of the aspects concerning the Active Directory. So we have stopped the last time and stopped at a certain point in the Testomo report concerning the domain findings or the Testomo report findings concerning the domain. We all know that the report is divided into sections. If we go up, this section is the summary, and then this summary contains all of the findings concerning all of the findings concerning what or concerning the Active Directory in general, and then he will begin focusing the findings on the forest, then on the domains, then on the domain controllers in a certain domain. So we have finished the findings of the report concerning the forest, the successful tests and the failed tests. Okay, we have discussed both why we were successful and why we have failed and how to rectify the failed tests. Okay, so today we will continue working with the domain findings. Okay, we have stopped at the point, let me get to it. Concerning the net login owner, we all know that there is a folder called net login. This folder contains the scripts that will be applied to all of the users in the domain. This test makes sure that the owner of this folder is the built-in administrators of the domain controller. So this, in very short terms, he is focusing on the permissions. If the permissions set on the netlogin folder is not correct, you will find problems concerning applying login scripts to your Active Directory users. So here he is focusing on the folder and the owner of the folder. So for example, here is the netlogin folder. This is my computer.bat, which is the script I have created to be applied to all of my users in the domain. Here is some info about it. It's okay, so he can find the script. This is the domain. This is the extension of the script, the creation or when it was inserted in the folder, netlogin, last access, last write time, its attributes, okay, the owner, then the SID, okay, and this is a well-known administrator, the owner type, and this is by the way, the netlogin folder, it is within or it is inside the sysvol folder. So this test make sure that you have the correct permissions set on the netlogin folder. So if the permissions are not set correctly, the users will not be able to see the effect of the login scripts on them. Okay, so for example, I have a login script that will apply a certain registry keys, okay, to the users. Some of them will, these registry keys will insert the Arabic keyboard layout. Some of these registry keys will disable some visual effects concerning the Windows. So all of these registry keys are applied using the Active Directory login script, which is inserted or it is within the netlogin folder. So if the permission set on this login folder is not correct, then my script will not be applied. So this is one of the tests, and I have succeeded in passing it. The next thing is the DNS scavenging, which is a very important concept we need to focus on and we will see the AI tools describing in details what is the DNS scavenging. But before that, I need to continue with my video just to make sure if I have anything applied to my domain. So here I will take, this is the command, I will take it and run it in my or on my domain controller to see the effect. We all know that every part of the Testomo report you can every part of the Testomo report or every test run by the Testomo report, you can run it individually by a custom PowerShell command. So let's see when I try to run the custom PowerShell command concerning the net login folder owner. I'm just trying to change or insert the forest name. Then we will insert the domain name for our domain, kmatrix.internal, and then we will see the data concerning the net login. Here we can see very detailed info. This is the info that was listed in the report. Okay, so the administrators or the built-in local administrators group, it is the owner of the net login folder. And by the way, this is the share name for the folder named scripts. So the original name of this shared folder, it is scripts. So scripts, its share folder name is net login. So if I am telling you that I am talking about the scripts folder, or I'm talking about the net login folder, the same, or I'm talking about one folder. This is the real name of the folder. This is the share name of the folder. The scripts, it is under sysvol folder. Okay, so this is one thing to note. Okay, and we can see this is the SID and a lot of info concerning the last access on the script, the last write time, the creation time, and a lot of useful information. So the next thing is the DNS scavenging. We will see, or I need to discuss what is first DNS scavenging. Okay, I have a lot of explanations concerning the DNS scavenging. First, we will see the perplexity answer, and then it is a little bit complex answer, or it is an IT or heavily, he's using heavily IT terms. Okay, we will see first the technical explanation of the DNS scavenging, then we will see the normal layman terms explanation of DNS scavenging, or the simple explanation of DNS scavenging, to let us or to explain this to the non-technical IT members or the non-technical personnel. Okay, so we have the two views, the technical explanation of DNS scavenging and the non-technical explanation of the DNS scavenging, so we can make it more easier to understand. Let's first see the DNS scavenging concerning perplexity, and he's here discussing what is DNS scavenging, and he is getting or giving you the resources concerning his answer. Very good, because he is getting the answer from a lot of resources and he's summarizing them in this answer, and is giving you the answers or the references he got his answer from. So let's see first the answer of perplexity and read aloud, or read it loudly.
Understanding DNS scavenging. DNS scavenging is a maintenance process used primarily in Windows Server environments to remove stale or outdated DNS records from a DNS database. This process helps to keep the DNS server's records current, reducing the potential for errors in name resolution and improving overall system performance. How DNS scavenging works. DNS scavenging operates based on timestamps associated with DNS records. When a DNS record is created or updated, it receives a timestamp. Over time, if a record is not refreshed, it may be marked as stale. The scavenging process identifies these stale records and removes them from the DNS database. The key components of DNS scavenging include Aging and scavenging. Aging is the process that determines when a DNS record is considered stale. Scavenging is the actual deletion of these records. Both processes rely on two intervals: the no-refresh interval, the time during which a record cannot be refreshed, and the refresh interval, the time allowed for a record to remain active after being refreshed. The total duration before a record is scavenged is the sum of these two intervals. Automatic versus manual scavenging. Scavenging can be configured to occur automatically at set intervals, or it can be performed manually by an administrator. Automatic scavenging is generally recommended for larger environments to ensure records are routinely cleaned up without requiring constant oversight. Benefits of DNS scavenging. The primary benefits of DNS scavenging include improved performance. By removing outdated records, the DNS server can operate more efficiently, leading to faster name resolution and reduced load. Reduced risk of errors. Stale records can cause name resolution issues, leading to service disruptions. Regular scavenging minimizes these risks. Enhanced security. Clearing out old records can help mitigate security vulnerabilities, such as DNS cache poisoning, by ensuring that only current and valid records are present. Potential issues with DNS scavenging. While DNS scavenging is beneficial, it can also lead to problems if not configured properly. Accidental deletion of active records. If scavenging is misconfigured, it may remove records that are still in use, causing disruptions in network services. Replication issues. In environments with multiple DNS servers, if records are not properly replicated, valid records may be incorrectly marked as stale and deleted. Impact on dynamic DNS. Devices that use dynamic DNS, DDNS, to update their records may not function correctly if their records are mistakenly scavenged. This can lead to connectivity issues for those devices. To prevent these issues, it is crucial to carefully configure scavenging settings, regularly review DNS records, and test the scavenging process in a controlled environment before full implementation. In summary, DNS scavenging is a vital process for maintaining the health and efficiency of DNS servers, particularly in dynamic network environments where devices frequently join and leave the network. Proper configuration and management of this process are essential to avoid potential pitfalls while reaping its benefits.
So this is one answer of Perplexity. Let's see the answer of Claude concerning the DNS scavenging, and here he is trying to explain it also in technical terms, but in more simple terminologies, okay, just to make it sure to be more easy to understand. Okay, so if we try to tell him to read loudly.
Would you like more information on how to set up DNS scavenging or its best practices? DNS scavenging is an important concept in network management, particularly for dynamic DNS environments. Let me explain it in simpler terms. DNS scavenging is like a cleaning service for your DNS, domain name system, records. Here's a breakdown. Purpose: DNS scavenging automatically removes old, outdated DNS records that are no longer needed or valid. It's a way to keep your DNS database clean and efficient. Why it's needed? In networks that use dynamic DNS, where devices can automatically update their own DNS records, the DNS database can accumulate a lot of stale records over time. These outdated records can slow down DNS queries, cause confusion or conflicts, waste storage space. How it works: DNS records are given a timestamp when they're created or updated. The DNS server periodically checks these timestamps. Records that haven't been updated for a long time, as defined by the administrator, are considered stale. These stale records are then automatically removed. Benefits: keeps the DNS database clean and efficient, reduces the risk of IP address conflicts, improves overall network performance. Considerations: it needs to be configured carefully to avoid accidentally removing valid records. Not all DNS records should be scavenged, like static records for important servers. To use an analogy, DNS scavenging is like a librarian who goes through the card catalog, DNS database, and removes cards for books that haven't been checked out in years. This keeps the catalog current and makes it easier for people to find the books, or in this case, network resources they need. It's important to note that while DNS scavenging is useful, It should be implemented carefully. Incorrectly configured scavenging could potentially remove important DNS records, causing network issues. That's why it's typically configured conservatively and monitored closely by network administrators. Would you like more information on how to set up DNS scavenging or its best practices?
We will see that in a moment, but this is the DNS scavenging uh, answer by Claude AI. Let's see ChatGPT. Here I'm asking it to also explain DNS scavenging in simple terms. Let's see what is the answer here.
DNS scavenging is a process used to clean up old or outdated information from a DNS, domain name system, server. Think of it like cleaning out your contact list on your phone. Over time, you might have old numbers or contacts that you no longer need. DNS scavenging automatically removes these old records to keep the DNS server tidy and efficient. Here's a simple breakdown. 1. DNS server. Think of this as an address book that helps your computer find websites on the internet. 2. Records. These are like the contacts in your address book, pointing to where websites are located. 3. Old records. Sometimes websites or devices might change their addresses or stop existing, leaving old, useless records. 4. Scavenging. This is the process that automatically checks for these old records and removes them, ensuring the address book DNS server is up to date. So DNS scavenging helps keep the internet running smoothly by regularly cleaning up the old unused information from DNS servers.
So here is the explanation of DNS scavenging. It is removing the old DNS records that was not updated for a certain amount of time. Okay, what is this certain amount of time? How it is calculated? There is two things that the DNS scavenging depend on when it wants to delete a record. It is the refresh interval and the non-refresh interval period. So you have two periods. Normally they are 14 days. If for 14 days the record was not refreshed or updated, it will be deleted. So the DNS scavenging depend upon two intervals or two time intervals before deleting the record, or consider it as an old record. It is the refresh interval and the non-refresh interval. What is the refresh interval and the non-refresh interval? Let's see here the answer of Perplexity, and then also we will see the answer of Claude and ChatGPT to make or to have the full view about the DNS scavenging process.
DNS scavenging, no refresh and refresh intervals. In the context of DNS scavenging, the no refresh interval and refresh interval are critical parameters that help manage the life cycle of DNS records, particularly in environments where dynamic updates are common, such as those using DHCP. No refresh interval. The no refresh interval specifies the duration during which a DNS record cannot be refreshed by a client or DHCP server. This interval is designed to prevent frequent updates to the same record, which can lead to unnecessary traffic and processing overhead on the DNS server. Purpose: it ensures that records are not updated too frequently, allowing for a more stable DNS environment. Typical duration: the no refresh interval is often set to a value that balances the need for record stability with the operational requirements of the network. For example, a common setting might be 7 days. Refresh interval: the refresh interval is the period during which a DNS record can be updated after its timestamp has been refreshed. Once the no refresh interval has elapsed, the record can be refreshed, which updates its timestamp and keeps it active in the DNS database. Purpose: it allows active records to remain valid and prevents them from being scavenged prematurely. Typical duration: similar to the no refresh interval, the refresh interval is often set to 7 days, meaning that after the no refresh period, a record can be refreshed and remain valid for an additional 7 days. Combined effect on scavenging: the combination of the no refresh and refresh intervals determines how long a DNS record can exist before it is eligible for scavenging. Specifically, the total time a record can remain in the DNS database before being marked for deletion is the sum of these two intervals. For instance, if both the no refresh and refresh intervals are set to 7 days, a DNS record can exist for a total of 14 days, 7 days of no refresh and 7 days of refresh, before it is considered stale and eligible for scavenging. It is important to configure these intervals in relation to the DHCP lease duration to ensure that records do not get scavenged while devices are still active on the network. For example, if the DHCP lease is 14 days, setting both intervals to 7 days would be appropriate. In summary, the no refresh and refresh intervals are essential components of the DNS scavenging process, helping to maintain an efficient and accurate DNS environment by managing the life cycle of DNS records effectively.
So this is how we can know the scavenging process. So it is very, very detailed and very, very organized. We can see here, this is the some screenshots, which is very, very good concerning Perplexity. Perplexity here gives you all of the info concerning the topic you are searching for. So it's giving you screenshots. Okay, he will give you, so this is very, very informative diagram. You can see here the run refresh, then the refresh, then it is expired, then it is deleted. Okay, very, very good example. And we can see here a lot of screenshots. We will do that in the video. We will enable scavenging after 7 days. So this a lot of things concerning the scavenging and a lot of videos how to configure scavenging. We will see how we will do that in a moment. So this is the answer of Perplexity. Let's go and ask Claude the answer, or what is the non-refresh and refresh intervals. Let's see the answer of Claude, and we will tell him to explain it in simple terms or in non-technical terms. So let's see that. Okay, so we can go there and ask it to read it loudly.
Would you like me to elaborate on any part of this explanation? Let me explain DNS scavenging and its intervals in simpler terms. DNS scavenging is like a cleanup process for your computer network's address book. It helps keep the address book, called DNS records, up to date by removing old and used entries. Now, imagine this process has 2 timers. Non-refresh interval. This is like a do not disturb period. During this time, even if a computer uses its address, the system won't reset the cleanup timer. It's as if the system is saying, I know you're using this address, but I'm not going to change anything just yet. Refresh interval. After the non-refresh interval ends, we enter the refresh interval. Now, if a computer uses its address during this time, the system will reset the cleanup timer. It's like saying, okay, you're still active, so I'll keep your address in the book for longer. If a computer doesn't use its address at all during both these intervals, its entry in the address book is considered old and may be removed during the next cleanup. This 2-stage process helps balance between keeping the address book current and not overwhelming the system with constant updates. Would you like me to elaborate on any part of this explanation?
Very, very good explanation, and we can see discovering all of the aspects of the DNS scavenging. Let's see the last answer of Claude concerning the refresh and non-refresh intervals, and then we will get a real-world example.
DNS scavenging involves 2 key intervals, the non-refresh interval and the refresh interval. These intervals help manage and clean up outdated DNS records. Here's a simple explanation. 1. Non-refresh interval. What it is. A period during which updates to a DNS record are not allowed. Why it matters. This helps prevent unnecessary updates to the DNS records. Think of it as a cooling off period where no changes are allowed. Analogy. Imagine you just added a new contact to your phone. The non-refresh interval is like a time frame where you can't change the contact's details, ensuring that any new information doesn't constantly overwrite the existing one. Number 2. Refresh interval. What it is, a period after the non-refresh interval when updates to the DNS record are allowed. Why it matters. This allows the DNS record to be updated with any changes, like if the address of a website has changed. Analogy. After the cooling off period, the refresh interval is like a time frame when you can update the contact's details if something has changed. How they work together. Non-refresh interval prevents changes to ensure stability and avoid unnecessary updates. Refresh interval allows changes to update the record with any new information. Together, these intervals help maintain a balance between keeping DNS records up to date and preventing constant, unnecessary updates. After both intervals have passed, if a DNS record hasn't been updated or accessed, it's marked for removal, scavenged, to keep the DNS clean and efficient.
So now we will get a real-world example. Here I'm saying I have a domain named matrix.internal. I have a PDC. This is its name, and ADC, this is its name, and I have a new PC that wants to join the domain. Let's see the scavenging process concerning this new computer joining the domain. So let's see the answer and see how this is applied, or how the concept of DNS scavenging is applied to this process.
Sure, let's walk through the DNS scavenging process with your example. Scenario setup: domain, matrix.internal, primary domain controller PDC, DCSM125, additional domain controller ADC, DCSM0225, new PC. Step-by-step DNS scavenging process. 1. Joining the domain, new PC, SM01. When SM01 joins the domain matrix.internal, it registers its DNS record with the domain's DNS servers, DCSM0125 and DCSM0225. This means that SM01's IP address is now stored in the DNS records of matrix.internal, allowing other devices in the domain to find and communicate with SM01. 2. DNS record creation, DNS entry. The DNS record for SM01, e.g. SM01.matrix.internal, is created with its IP address. This record is stored on both DCSM0125 and DCSM0225. 3. Non-refresh interval, cooling off period. Suppose the non-refresh interval is set to 7 days. During these 7 days, the DNS record for SM01 cannot be updated. This is to prevent constant and unnecessary changes. The record is stable and not allowed to change during this period. 4. Refresh interval. Update allowed. After the 7-day non-refresh interval, the DNS record enters the refresh interval. Let's say the refresh interval is also set to 7 days. During these 7 days, the DNS record can be updated if there are any changes, e.g. if SM01's IP address changes. 5. Scavenging eligible. Ready for cleanup. After both the non-refresh and refresh intervals have passed, total 14 days in this example, the DNS record for SM01 is now eligible for scavenging. If SM01's DNS record hasn't been updated or accessed during these intervals, it might be considered stale. 6. Scavenging process. Cleanup time. The DNS servers, DCSM0125 and DCSM0225, periodically run the scavenging process. During this process, they look for DNS records that haven't been refreshed or updated within the combined non-refresh and refresh intervals. Record removal. If SM01's DNS record hasn't been updated or accessed in the last 14 days, it will be marked as stale and removed during the scavenging process. Real-world example 1. Day 1. Join domain. SM01 joins matrix.internal and registers its DNS record with DCSM015, DCSM025. DNS record created. A DNS record for SM01.matrix.internal with its IP address is created. 2. Day 1-7. Non-refresh interval, SM01's DNS record is stable and cannot be updated. 3. Day 8-14. Refresh interval, SM01's DNS record can now be updated if needed. 4. Day 15. Scavenging eligible. If SM01's record hasn't been updated or accessed, it is now eligible for scavenging. 5. Periodic scavenging, cleanup. During the next scavenging cycle, DCSM0125 and DCSM0225 will check and potentially remove the stale DNS record for SM01. This process helps ensure that the DNS records on DCSM0125 and DCSM0225 are kept up to date, removing any outdated entries that are no longer valid, which helps maintain the efficiency and accuracy of the DNS system in the domain matrix.internal.
So this is the DNS scavenging. You will see that the report here is saying that I don't have, or I didn't set up the DNS scavenging. There is no DNS scavenging interval. There is no scavenging state, or the scavenging process is not initialized. Last scavenging time. So in short, I don't have any scavenging option enabled. Okay, so we need to set up the scavenging process, the scavenging interval, the scavenging state, if it is initialized or not. See, we need to see or we need to activate all of these. Okay, so here we can see that this is the data, but I didn't have DNS scavenging on both domain controllers, or that contains primary or two DNS servers. Let's see here. When I asked Claude to give me the steps for DNS scavenging, here is the steps for DNS scavenging. Okay, this is how we can do that. So here is, you can see here, we will see that in the video how we can do DNS scavenging. This is the answer of Claude. We will do this one by one. Let's first ask, by the way, I'm just listing the answer, and then we will see how we can apply it practically. If we go there and ask it to, or go Perplexity and ask to give us the DNS scavenging setup guide and best practices, and then we can go and ask it the same answer here for ChatGPT, we will see that here it gives us the steps. We call the DNS manager, and then enable, and then advanced view, and then we can update static records, review all records, and set essential records, domain controllers to static. It's already static. I think it's already a static record. This is one good thing to see here, because you need to go to the domain controllers and make sure that the DNS records are static, and to uncheck delete this record when it becomes stale. Very, very important note, because I have already enabled scavenging, but I didn't take a look on the domain controllers DNS records. We need to make sure that the option delete this record when it becomes stale to be unchecked. This is very, very important thing, because this means it will delete the DNS record for the domain controller if I didn't log in for 14 days. So this is a good thing to do. Enable DNS scavenging. Okay, this is the steps. Okay, and very, very good, because actually DSP lease here is 8 days. Anyway, so this is the steps how we can do that. We can go and do that or we'll do that in a moment. We'll show you what we need to do. And here is the best practices. Enable scavenging on only one DNS in the environment. So we need to do this on one DNS server. This is strange. Okay, this is one good thing to note actually, because actually I did it on both DNS servers. Set the refresh and non-refresh intervals. We have seen this 7 and 7 days, but make sure that the HTTP lease is 8 days. Okay, just to make sure that the IP is not changed during the non-refresh interval. So it is by default 8 days on the DHCP, so you don't need to worry. Okay, this is one thing. Test the scavenging in a control environment. We need to make it in a virtual environment or a test environment. Protect accidental deleted. This is the one important thing. We need to see the static records in the DNS and make sure it will not be deleted. The static records are for all of our servers. We need to make sure that the option that is called delete this record when it becomes stale, this should be unchecked. Very, very good thing to note. Monitor the DNS event logs. Okay, he's getting the logs. Very, very good answer. Actually, I am impressed. Track the scavenging process. Use a PowerShell script to automate the removal of DNS records for VPN connections with separate DHCP pools. This can be elaborated more, because I don't have a VPN connection. Okay, this should be one good thing. Very, very good answer actually. Very, very good answer. Let's see. Okay, I think I have already read the answer. Let's go and see ChatGPT and see the answer here. He is saying that these are the steps. Okay, we will do that in a moment. Non-refresh. enable scavenging, advanced, we will do that, manual trigger. If you need to make scavenging spontaneously or at the same moment, you can trigger it, or you can make it an automatic scavenging after 7 days. Okay, this is the refresh and non-refresh intervals. Backup DNS data, we need to make sure to back up your DNS. I think this can be done if you are taking backup of the Active Directory database. You will take backup of the DNS records as well, because the DNS records are integrated with the Active Directory database. Okay, gradual implementation, test and environment, very good answer. So good, let's see how we can do that from the video. So this is the, I have a one I was having, or I have a PowerShell script that enabled DNS scavenging, but anyway, I didn't find the script. So let's go and see how we can do this from the domain controller. Let's see how we can do this manually, or we can do this without a script. So we can go and see the process. No, we need to go again. I think let's go further. I need to see. Okay, here you go. 1 minute. Okay, we can go a little bit further here. Okay, so let's see how we can do this, the scavenging. So here I'm just querying ChatGPT 4o for the process of the scavenging. So you need to go and do that step by step. Here you go. We need to go to the primary domain controller. So as a best practice, we need to do the scavenging on one server only. Okay, this is the best practice. So here we need to go and do the steps one by one. First of all, we need to go and open. This is the additional domain controller, and here is the DNS. We need to right click and properties, set aging first. This is it. So this is the first thing, to set aging. Here we will define the refresh and non-refresh intervals. We will right click and set aging, and then put 7 days, 7 and 7. So this is good. So this is a good thing. We need to go and continue. Okay, I need to check also, apply this setting to the existing Active Directory integrated zone. We need to check that. Okay, we will check that, by the way, don't worry, we will check that. So again, I am just cautious for doing this setting. Okay, so if you can go further there and do like that again. So here, this is the DNS scavenging that I asked Claude the same question like ChatGPT, and he's giving me the answers the same way. So we will go and repeat the process. Okay, you can do scavenging using commands. Okay, so anyway, so we will go and apply the scavenging. So we will go to our primary domain controller. Sorry, this is the additional, and then right click properties, again set scavenging, and then OK, and then apply. We need to make sure that the static records, we need to uncheck delete when it becomes stale. Okay, just to make sure it will not delete our static servers DNS records. Okay, so now we had it, then we go to the we have done this on the server. Okay, it will be replicated. So this, I didn't actually configure it on 2. I have already done it on my additional or second DNS server, and it was replicated. All of the setting was replicated to my primary domain controller. So I didn't do actually anything on my primary unless or only for setting the automatic scavenging interval. So we will see that in a moment. This is my primary. If I go, you will see all of the settings was replicated. Okay, this is properties. So yeah, I'm just checking to see if the scavenging option is working. So we go to the properties, then advanced. Here, if you go there, we need to go to the properties and advanced to make sure that we have the enable automatic scavenging of stale records. Okay, we need to make sure of that. So we have set up the refresh and refresh intervals. The scavenging, I think it should be set to 14. So, oh my god, I have already made it for 7 days. This is not correct at all. We need to change the scavenging time. Here is saying that we need to put it, no, we need to put it to 14. I have done it with 7. This is not a correct period. We need to make it 14 days. So this is not correct at all. We need to make the scavenging of records to be 14, not 7. Okay, so this is not correct. We need to change it. So I need to make a small video to rectify the things concerning the DNS records. Okay, I will need to do that anyway, so it's not 7 days, should be 14 days. And then if we go to the here I'm checking the zones, DNS zones, to make sure that the aging, it is already aging after 7 and 7. Here I'm just checking every zone for each one of these. So if you go to the primary domain controller and see the DNS, okay, here you go, this is it. And then properties, or set scavenging, we will see it's already there. Okay, so it's already replicated from the secondary domain controller. We need to apply it to all of the settings. If we go and see the properties, then advance, we need to make sure automatic scavenging of stale records to be 14 days, not 7 days. This is not correct. I need to make sure something here. If I go there and it's by default 7 days. Yes, if you go and right click and properties, see where it is here, we tell him enable automatic scavenging. So it's already by default 7 days. So this is strange, because if the scavenging period is enabled 7 days and the refresh interval is 7 and 7, so this is strange. Should I make it 14 days, or should I leave it to the default, which is 7? I think we need to make sure why it is 7. So it's by default 7 and 7, then this should be by default 14. Why it is set to 7? maybe after the first 7 days. Anyway, so let's see. I need to ask something here. Let me ask Claude here, because this is a very strange thing to do. When I set the DNS non-refresh and refresh intervals, it is by default 7 days for both, and when I enable let's get the option here, enable automatic scavenging. I think not. Let's see. Okay, let me go and ask it. It is 7. Is this correct? So let's see that, because he is breaking it down. You are on the right track. Let me clarify a few points. Default intervals. Yes, you are correct. The default setting for both non-refresh and refresh interval is 7 for each, which means the total scavenging cycle is 14 days by default. Scavenging period. When you enable automatic scavenging, you are asked to set a scavenging period. This period determines how often the scavenging process runs. The default for this is indeed often set to 7. Let's break it down. Non-refresh is 7. Refresh is 7, scavenging is 7. This means by default the system will check for stale records every 7 days, but records need to be unused for 14 days. Okay, so it will check every 7 days for stale record, but 14 before it's considered stale and eligible for removal. It's important to note that setting can be adjusted based on your setting, so and so. So he's saying that this is the correct setting, or I don't see any it is correct. Non-refresh interval 7 by default. So this means by default the system will check for stale records every 7 days. So this is the scavenging period, 7 days, but a record needs to be unused for 14 days. So enable scavenging period every 7 days. He will check if the record is, this is the scavenging process. He will check, or he will do the scavenging process every 7 days. If he find a record that was not used for 14 days, it will be deleted. So this is makes me a little bit more little bit more not worried, because I thought it will delete it after 7 days. The enable scavenging period after 7, default when enabled. So he's saying that the 7 days, it is the default thing when enabled. Let's just to make sure, let me ask again Perplexity, just to make sure that this is correct. Just to make sure that I am on the right track. Okay, 7.7. Okay. However, enable automatic stale records has a separate setting for scavenging period, which default to 7 as well. This means that even though a record might be eligible for scavenging after 14 days, the actual scavenging process will run once per week. Okay, so this is good. Here we can know that the scavenging period will run twice a week. Will run once per week. So the process will run after 7 days and another time after 7 days. it will delete the record if it is not used for 14 days. This is very, very good. Now we can know exactly enable us to run every 7 days. So this is correct. Very, very, very good. Now we can rest sure it will not delete it after 7 days. Can be potentially exist for 15 to 20 days before deleted by the scavenging. Very, very good. Now I am not worried again. So just to make sure that I have the same answer to Claude. The good thing here, let's give you a practical example here to clarify the issue. Here, if you see here, this is day 1. This is the record for a PC. We wait for 1 to 7 days, non-refresh interval, then 18 to 48 days, refresh interval. Day 15, if the record has been updated, it becomes eligible for scavenging. For 15 to 21, the DNS runs the scavenging process every 7 days. Please find the record. It has been updated. Okay, so that's good. Very, very good. So this is correct, and they are all ensuring that the default scavenging period or automatic scavenging period, it is 7 days. So now we can rest assured it will not delete it by mistake. But we need to make sure that the static records, we need to uncheck delete when it becomes stable. So very, very good. We can continue working. So I thought I was mistaken, but again here, this is the aging. This is already replicated. We can see we need to make sure that our records, these are static records, we need to make sure that uncheck the option deleted when becomes stale. These are all servers. This 1, 2, 3, these are 3 servers. We need to make sure all of our servers that are using static IP addresses, we need to uncheck delete when it becomes stale. This is good. This is for my PC, and it's using the DHCP. This is dynamic IP address. Okay, so very, very good. Okay, so now I'm checking if everything is working properly. So now we have everything set. Okay, and then after doing all of these, we can run the test again to make sure that we have passed the point of DNS scavenging. Let me first see if we have bypassed our time. No, I think we have still enough time. Okay. So I think here we can have already the scavenging process. It's already explained and well explained. So we can go and continue with the other points. First, we need to run the test of the scavenging. So we will go there and go to the report and take this command and run to see if we have all of these are passed. Okay. Okay, as we can see here that here the refresh intervals are done, the scavenging state is true, the scavenging state is true. So when the refresh intervals are done, the scavenging interval is done. So we have all of the settings done. So we have passed this test. Okay. So now we can go and continue with the other test. Now we can go, and before that the scavenging interval was not set, so now it is set. Now we have the scavenging state or scavenging interval done, and it's true. Here is 0 0, we have it 7 days, so we have all of these already done. Okay, DNS forward, this is we have already done in the beginning of the setup of our DNS. This is to forward the requests for external DNS servers to resolve IP addresses of our websites or external websites, or to resolve IP addresses from outside our domain. Okay, not to resolve IP addresses concerning our PCs or our servers. This is when we need to access the internet and we need to resolve the IP addresses of the websites. We need to make DNS forwards. We need to make our DNS servers forwards the request to resolve IP addresses of websites to external DNS servers like Google server and so on. So we have done this before. Okay, aging primary zone, we have seen this. Aging primary DNS zone, we have already done this, and DNS aging should be identical. This is already, we have done it from a couple of seconds, so we don't need to worry also about the test. We have already done that. So we can run it again to make sure that we have passed it. Now we can put the domain and the forest, and then we can see if our aging or scavenging age is the same on all of our DNS zones. Here we can see here also that here is getting us all of the status of the DNS servers. We can see, okay, we can here make sure that our aging is the same, or the scavenging aging or the scavenging period is the same on both servers or both DNS servers. Here we can see another test here. Let me show you all what this test is talking about. If you go to the test here, we can go to DNS forwards. Okay, we have seen this test. Okay, and then can go to aging. Okay, we have done this test actually. This is the data concerning the DNS zones. Okay, we have the primary zone. It is a PDC. Okay, this is a DNS or primary DNS, and it's a PDC or primary domain controller. This are aging is enabled. Okay, you can see that it is enabled here. Okay, I think he is talking about the PDC, and this is one is true, so this is my PDC and this is my ADC. He is checking the DNS aging or scavenging interval on both DNS zones on my primary and additional domain controller. If you go there, this is it. This is my primary domain controller and the additional domain controller. These are the DNS zones on both the primary and additional domain controller. Reverse lookup zone, it is integrated. Okay, DNS are integrated. Okay, so we can see the dynamic updates or DNS dynamic updates is secure, and we can see replication here, I think. Anyway, so this is the primary and this is the additional, so we can see it is there. If we go and see the other test, which is computers, here it's checking if all of the computers or the computer objects in the Active Directory, all of these computer object has a password. So every user to log into the domain should have a password, and every computer logging into the domain should have a password. Okay, the computer password is always required. It is expired. The password is not reverse. Okay, I mean it's not clearly you cannot see it clearly, or something like an encryption. Okay, it's not reversible, or a type of password encryption. I think it's not reversible. The Kerberos encryption is set to RC4. Primary group is always domain computers. So he's checking that all of the computers that join the domain should be a member of a group called domain computers. And if it is a domain controller, it should be a member of the domain controller's computer group. Or if it is a read-only domain controller, it should be in the group or the computer group, which is called domain read-only controller. So he's checking all of these standards. You need to make sure that the computer objects have a password, it's expired. By the way, the password of this computer is set automatically by the computer or the host itself or the client itself. So the password is not set by the user, it is set by the computer. The computer password is set by the computer itself. Okay, and it is it can access the Active Directory and set its own password. The computer will set its own password in the Active Directory. Anyway, so these are all of the settings. We need to make sure that it is there. So you will see all of the computers have a password, it's expiring, the password is not reversible, Kerberos encryption is set to RC4, so because there is a secure connection between the domain controller and the client, it should be using the Kerberos. So the Kerberos will authenticate and it will encrypt the connection between the domain controller and the client. The encryption type should be RC4, and the member, checking the membership of the computer group, computer objects, if it is in the domain computers group or domain controllers group or domain read-only controllers group. So here he will check that, and then we will go something. The next tasks are security delegated object. If you are making delegation for a computer or something. Anyway, I think this is related to delegation of rights, but let me check or ask Claude to explain this. Okay, explain this statement, because I need to make sure it's talking, or I'm talking about the correct subject. Let's go and ask Claude. Let's first open this one. No, I think I need to open it back. Just a moment. So here, this is the one concerning. Okay, let's go and tell him to explain this in layman terms. Okay, so here you go. Now we can go and say this one. This is the test. Here he is having a test which is called security delegated objects. We need to see what this test will do exactly. So I'm asking Claude to explain what the test is doing. Okay, so he is saying that, let's break it down. Okay, he's saying Kerberos delegation. It's like giving someone permission to act on your behalf. It's evolved over time to be more secure with three main types. This is the delegation or Kerberos delegation. Unconstrained full delegation is like giving someone your master key. They can do anywhere and do anything you can do. It's the oldest and least secure method. Example, if you give the office manager your master key, they could access any room in the building, even one you didn't intend them to enter. Constrained delegation is like giving some one a set of specific keys. They can only access certain places you have allowed them to. It's more secure. Okay, so this is one thing. So for example, you can give the office manager the key to supply room and conference room, okay, but not the executive office or the server room. This is the second. This is the types of delegation: unconstrained delegation, constrained delegation, and then resource-based constrained delegation. This flips the control. Instead of you deciding who gets access to what, each room decides who is allowed in. It's the most flexible and secure method. Let's see an example here. In the IT department, you can decide who accesses the server room rather than having to manage the access for every employee. Okay, but we need to have a practical example to explain it more. The main difference is unconstrained, very risky. Okay, constrained better. Resource based is the most flexible one. As time passed, the message was more refined to improve security, so and so. Give me a real world example, a domain named matrix.internal, okay, with a PDC and ADC. Let's see how you will explain that. So let's see that and how he explained this, the delegation, or how he explained the delegated objects test using a real world example. If you go there and see here, just a moment, he's saying that let's use a real world example. We have a domain name matrix internal which has a primary, okay, PDC and ADC. We call the PDC NeoPDC and ADC Trinity.ADC. Here is how the different types of corpus delegation might work in this scenario. Unconstrained fault delegation. Let's say that you have a service account named Morpheus SVC, an account or Active Directory account, which is a service account used for a custom application. Okay. Example: the IT admin configures Morpheus with an unconstrained delegation. Oh, so this is a good one. Now, if a high privileged user like a domain admin logs into any server with Morpheus SVC is running, Morpheus could potentially access any service in the matrix internal as the domain admin. So he's saying that if you give unconstrained delegation to a service account, then he will act the same as the domain admin. Okay, so he's giving all of the rights of the domain admin to a service account. This is the unconstrained delegation. Okay, so this is very, very harmful. Potentially access any service. This includes accessing sensitive data on NeoPDC or Trinity with a significant security risk. So this is a good example. Constrained delegation, IT team realized it's too risky and decides to use constrained delegation instead. They configure the service account to only have delegated access to a specific database called Oracle DB, okay, which is on a file server. Okay, very, very good example. Okay, now even if a domain admin logs into a server with Morpheus service account is running, it can only access the two specific servers on behalf of users, not everything in the domain. So here is delegating the access or the rights of the domain admin to a certain server, so he can go and access the Oracle DB only and change or play with it only on the DB, not all of the servers. So he's delegating his rights to a certain server. The domain admin will delegate his rights to the service account, and this will only work on a certain server. Okay, so this is good. He is only access the two specific servers on behalf of users, not everything in the domain. Based or resource-based constraint. As the company grows, managing these delegations become complex. They switch to a resource-based constraint delegation for better control. Okay, so again we need to read this one. This configure this to only have delegated access to specific database server, okay, and the file server. So you have access to two servers in a specific, okay. Now even if a domain admin logs into a server where this service account is running, it can only access these two specific servers on behalf of users. Okay, this is clear as crystal. If you go and see the resource-based constraint delegation, let's see an example. Instead of configuring Morpheus service account with a list of servers it can access, the IT team goes to Oracle DB, the database server, the file server directly. On each of these servers, they specify that this account is allowed to access them on behalf of other users. This way, if a new service needs access, the owners of Oracle or Xeon can grant it themselves without needing to involve central IT to reconfigure Morpheus. This should be okay, so let's see this one. Is allowed to access them on behalf of the users. So in this way, if a new service account needs access, the owners of DB can grant it. Okay, so he's giving the access, or he's delegating, or the owners or the administrators of the database server or the file server will be responsible for granting service accounts access to their server. Okay, so this is based on the server itself, not from the IT itself, to involve central IT to reconfigure Morpheus. So this is good thing, very very good example, and it helps me or helps you or us to know these types of or what this test do. So it will see if I have delegated objects, if I have constrained delegation, unconstrained or constrained or resource based. I don't have any one of these delegations. I didn't make any delegation to any user. So this is one good thing to know. Okay, this is a good thing. So we have passed the computer standard test, then the delegation objects test. Then here he is saying that account operators should be empty. What is the account operators? I think we will stop at this, but to make a small brief, account operators are a group in the Active Directory that any member in this group can create users and groups in the Active Directory. So they can create users and groups in the Active Directory, and another thing, and members. So you can create users and groups if you are a member of the account operators in the Active Directory. So if you are a member in the account operators, you can create users and groups in the Active Directory and put group membership. So you can create users and groups and define the membership of users in the group. And by the way, you can do this. One of these groups that you can put the members in it, or to identify the members of a certain group, is the server groups, which is a very very also critical group we will talk about in the upcoming video. So we will stop at this test, but before that I need to run the video to see if we have anything missing, so we can go and continue computers. So let's continue. So here we will see the delegation, or this is the delegated object tests. We need to make sure if I have anything delegated, but we will not see anything. So here I'm just making sure that I don't have anything delegated. Matrix.internal, or this is matrix. So see here, these are all accounts, but don't have any delegation. By the way, I didn't do any delegation. It is only trusted for delegation, but I didn't make any delegation. Okay, so this is one thing to take note of it. Okay, so we will stop at this one, the account operators. Okay, we will stop at this one, and the upcoming video will continue working with the rest of the report. Hope this video informative to you all, and thank you all for viewing. Thank you so much.